All right. In this video, I'm going to go over what we call the von Neumann and Morgenstern method for setting utility values on an interval scale. So this is explained in the chapter on page 89. And in addition to looking at the chapter, you should also look at the notes that I've posted. In this video, I'll just illustrate the process, go through the process to show you what it looks like when you're doing it. Let's imagine that we have this decision problem, and each of these outcomes is a free trip, either to Tokyo, London, Mexico City, or Barcelona. So if we're going to set utility values for these outcomes, the utility value for getting the trip to Tokyo, a utility value for getting the trip to London, one for Mexico City, and one for Barcelona, the first thing that we have to do is order these outcomes from most preferred to least preferred. So this will be different for different people. I'll do it for myself. It might be different for you. But for me, of these four outcomes, my most preferred is Tokyo. My second most preferred is Barcelona. Third is Mexico City. And fourth is London. Okay, so again, for you, the ordering might be different. These are all nice cities. I've been to some of them. I haven't been to others. And so just for me, I would order them this way. Now, if we were going to assign utility values on an ordinal scale, where all we care about is the order, we could do that pretty easily. We can just start with 1 and then give each one a higher number. Okay, so that's pretty straightforward. However, in this case, we don't want an ordinal scale. We want an interval scale. So instead, the first thing we do is assign the most preferred outcome, whatever it might be, Tokyo for me. We give that a value of 1, and we give the least preferred outcome a value of 0. So then our task is, and this takes a little bit of work, to figure out what the utility values will be for the ones in the middle, in this case, Barcelona and Mexico City. Okay, so how do we set these values for Barcelona and Mexico City? We'll start with doing the one for Barcelona. And so to do that, I offer myself two choices. Okay, so I have two choices that I'm hypothetically offering myself. One is just taking the trip to Barcelona. So if I choose number 1, I would just get that. Or I enter a lottery. That's what the L stands for. And so if I enter the lottery, then I have some probability, we'll call that A, of getting my most preferred outcome, the trip to Tokyo, and some probability, 1 minus A, of getting the trip to London. Okay, and let me just say right now, so what we're doing here, making a choice between Barcelona and the lottery, is only for the purpose of setting the utility value for Barcelona. It doesn't have anything to do specifically with the decision problem itself. That's separate. Okay, so my goal right now, when I'm thinking about these two choices, is Okay, so my goal is to find the probability of winning the lottery, that is a probability for A, that makes me indifferent between getting Barcelona, just taking that, or entering the lottery. It makes me indifferent between getting one and two of my two choices. Or, in other words, I want to find the point at which I would be equally happy with either one. Okay, so what I have to do then is consider some probabilities of winning and losing the lottery, and then think about when those were the probabilities, would I just take number one? Would I take the lottery? Or would I in fact be indifferent? Okay, so again, this is going to be different for everybody. And so you can watch me go through the process, but this won't necessarily be the process for you. But for me, and I already thought about this, if the lottery was, or the lottery had a 60% chance of giving me Tokyo and a 40% chance of giving me London, as I have a 60% chance of winning or a 40% chance of losing. If those were the odds, then I would just take option one. I would just take the trip to Barcelona. So if I take one, that means that this probability is too low. So I'll consider a slightly higher probability, say 70%. So now I have a 70% chance of, if I enter the lottery, of winning the trip to Tokyo, and a 30% chance of getting the trip to London. And so if I think about it, do I want this lottery or do I just want to take the trip to Barcelona? And so for me, 30% chance of losing, but London's not such a bad outcome, I would take the lottery. I'd take choice two. Okay, so that means that this probability is too high relative to finding where I'm indifferent. So I need to find something that's lower, something that actually is between 0.6 and 0.7. So when I was thinking about this earlier, I tried 66, but that's actually not quite right. So I landed on 0.67. Okay, so if there was a 67% chance of winning the lottery and a 33% chance of losing it, if that was the lottery, or I had the option of just taking Barcelona, then I would be indifferent between the two. Okay, so with this probability, 67% chance of winning the lottery, I'd be equally happy to take either number one, trip to Barcelona, or number two, the lottery. Okay, so what does that mean? It means that my utility value for Barcelona is 0.67. So we come back here and I can put 0.67 on my list of utility values. Okay, now I have to do the same for Mexico City. I need a value that's going to go right there on our list. And so I do that the same way or similar way. Okay, so now my two choices are these. And so let me just make a note. When you're offering yourself these two choices, the first one, the one that you can just take if you want it, is the one for which you're setting the utility value. Okay, so this one here will, every time you do this, be different. But for the lottery, it's always going to be between the most preferred and the least preferred. Those stay the same. All right, so again, we need to think about some probabilities for the lottery. So when I was doing this earlier, I started out with 55 and 45. So if those were the probabilities, I would take the lottery. So that means the probability is too high. If I'm looking for the point at which I'm indifferent, so I can try 50, 50 chance. Still, so for me, London's not actually a bad outcome. I'd be satisfied with that also. So I would still take the lottery. Put an L there. If it was 50-50, 40-60. Okay, so I have a 40% chance of getting Tokyo, a 60% chance of ending up with London, or I can just take Mexico City. So for me, I would still take the lottery. So gives me a chance of Tokyo. I'd rather just try the 40% chance of getting that instead of just taking Mexico City. If I lose, I got a 60% chance of losing, I'll just end up with London. That would be fine. So I still need to go lower. So for me, if it came down to just a little bit lower, 35% chance of winning the lottery or 65% chance of losing. So at this point, got almost a 1/3 chance of winning, 2/3, almost 2/3 chance of losing. So if those were the odds for the lottery, I'd be equally happy with either taking the lottery or just selecting Mexico City and just getting that. So okay, so with this probability, I'm indifferent between choices 1 and 2. Okay, so what does that mean? That means for me, the utility value for Mexico City is 0.35. All right, so now I have utility values on an interval scale for all 4 of these outcomes. So to make a decision, my next step is just to put those values into the decision table. So Tokyo was 1, London was 0, Mexico City we just found was 35, and Barcelona, again, this is all for me, is 0.67. Okay, so once I have the decision, the outcomes represented in terms of their value to me, in terms of my utility values, I can calculate the expected utility for each option. Okay, so this is going to be similar to calculating the expected value, but instead of using monetary values, we're using these utility values. So for bet 1, I'm going to multiply 0.4 by the value of this first outcome, which we said was 1, plus 0.6 by the value of this outcome, which we said is 0. So the expected utility for me for bet 1 is 0.4. For bet 2, I have 0.4 times 0.35 and 0.6 times 0.67. So that's going to be 0.14 plus 0.4 equals 0.54. So following the expected utility strategy, I would pick the option with the higher expected utility, which is bet 2. Okay, so I'll stop there. In the next video, I will go through how we would do the same thing for this decision problem here.